This lesson is going to be on graphs of parent functions and trig functions. We're going to start with the trig functions first. This is just your basic sine graph. It should look very familiar to you. As you can see, it goes through 0, 0, and when x is pi over 2, sine is 1. When it's pi, sine is 0, -1, and 0 as well. Now we're also going to talk about the inverse sine function, or the arc sine function, or the sine to the -1. A lot of times it looks like this. Sine to the -1 of x. That just means the inverse sine function. Now, not the reciprocal sine function. Remember, the reciprocal of sine is cosecant. That's not what we're talking about. We're talking about the arc sine, or the inverse sine. That means when you're talking about the arc sine of something, you're saying the angle whose sine is. So you might be asked to evaluate the arc sine of 1/2, in which case you would say 30 degrees or pi over 6 in the first quadrant, because the angle whose sine is 1/2 is 30 degrees or pi over 6. Now when we start talking about the inverse trig functions, we have to think about what it means to be a function. Notice this sine curve passes the vertical line test. However, if you take the inverse of it, and if you remember to determine if the inverse of a function is also a function, you can look at the horizontal line test, and you can see that this function would fail the horizontal line test from -2 pi to 2 pi. But there is a region in here from about here to here where it would actually pass the vertical line test. So the graph of the inverse sine is only defined from -pi over 2 to pi over 2. And when we take a look at the graph, you can see that it's the inverse function. So the domain of the original becomes the range of the inverse, -pi over 2 to pi over 2. And the range of the original, -1 to 1, becomes the domain of the inverse. So this is what the function looks like. So oftentimes you'll have a question where you'll end up with, it'll say the sine -1 of 1/2, and you're going to tell me that the answer is 30 and 150, because the sine of 150 is also positive 1/2. The problem is these are not in the range, these are not in the domain of the arc sine function. So if it says sine -1 of 1/2, your answer is only 30 degrees or pi over 6, which is right in here somewhere. Hopefully that makes sense to you. Okay, let's look at the next one. Oh, where did my thing go? Whoop, whoop. Okay, this is the cosine function. Again, it goes through 0, 1, pi -1, 2 pi 1, and it crosses 0 at pi over 2 and 3 pi over 2. Again, this is not a one-to-one function. It would not pass the horizontal line test, but it is one-to-one from 0 to pi. So since 0 to pi is the portion of the domain that is 1-to-1, that becomes the range of the inverse, and it goes from -1 to 1 for the domain of the inverse. So the domain of the inverse is -1 to 1. The range of the inverse goes from 0 up to pi. And then the tangent function, looks like this. Remember, it's undefined at all multiples of pi over 2. It passes through 0, 0, and one full section of this is 1-to-1. So from -pi over 2 to pi over 2, the function is actually 1-to-1. And think about what the range is from -pi over 2 to pi over 2. What's the range of this function? It's from -infinity to infinity. So that means the domain of the inverse, the domain of the arc tangent, is going to be -infinity to infinity. However, the domain of this function is -pi over 2 to pi over 2 exclusive. There's an asymptote at -pi over 2 and pi over 2, which means that the range of the arctangent is going to have an asymptote at negative pi over 2 and pi over 2. So here you go. The domain is from negative infinity to infinity. The range is from negative pi over 2 to pi over 2 with asymptotes at both of those. So you have to keep in mind where these functions, the arctangent, arcsine, and arccosine, are defined, because there are not unlimited answers. There's only the answers that fall within the domain of the arcsine, arccosine, and arctangent. It may very well be a question on a quiz. Give the domain and range of the arcsine, arccosine, and arctangent functions. Okay, and then finally, I want to make sure that you have memorized, not all of these, I'm going to talk about the ones that are really important. Obviously, you need to know that a constant function is y equals a number. It's a horizontal line. Slope is 0. And I'm going to interchange f of x and y forever. They mean the same thing. So just keep that in mind. This is y is a function of x. So here y equals x is a line. Y-intercept is 0. Slope is 1. Absolute value looks like this. We can shift it left, right, up, down. We can make it fat or skinny. But the parent function is a v going through the origin. This is called the step function or the greatest integer function. We're not going to use that very much, so you will not have to memorize that. Quadratic and cubic you should know, and remember that when they become negative, when you put a negative in front of the x squared, this opens down. When you put a negative in front of the x cubed, it opens the other way. The end behavior changes. Here, the square root function, you have to know what that looks like. Don't care about the cubed root function. Don't worry about that. Exponential, you have to know that it goes through 0, 1, and that it's asymptotic to the x-axis. The log function, you have to know it goes through 1, 0, and it's asymptotic to the y-axis. Keep in mind these two are inverses of each other. The reciprocal function you have to know looks like this, but you do not need to know the rational function, and we already went over these three bottom ones. So it's really just 1, 2, 3, 4, 5, 6, 7, 8, 9 parent functions that you really have to have a good grasp on. Okay.